For example 3, we're asked to evaluate the expressions using the given value. With the other two examples, 1 and 2, we had a single value for the variable, and we were allowed to use that for all of the different problems. But here we have some different variables. We've got an x and a p, and there's a y over here, and another x, and then an x and a y there too. And we're asked to evaluate these for specific values in each individual problem. So be very careful when you read. In these different problems, this x is not the same as this x. If it was, that'd be a 4. Y is equal to 4 here, but then over here, y is negative 2. So just be very careful when you're working these problems and try to do each one on its own and not to mix up those different variables. So let's look at the first one here. We've got x cubed, that's our expression, when x is equal to 4. So what we can do is just use our parentheses here and take the x out, and then the 4 comes in for the x. 4 to the third power is the same as 4 times 4 times 4. That's what an exponent means. It's just repeated multiplication. So if we look at this, we've got 4 times 4, which is 16, and then 16 times 4, which is 64. For b, we've got a different variable, p. P is being squared, and p is equal to 1.25. Yikes, a decimal. Yes, decimals are numbers too. Be comfortable with decimals. So we can take the p out in the original expression, p squared. And we still need to square that value, though p is being squared, so 1.25 is going to be squared. I don't know about you, but I don't have this one memorized. 125 squared, 1.25 squared, or 12.5 squared. Yikes, I don't know what that is. So, oops, my batteries are low. I guess I'll have to get new batteries. And 1.25, and then if you use your calculator to do this, the key you want to press is this x squared. It will take whatever you've entered, and then it will square it. So if you push that x squared here, it'll put this squared sign up here. There's another way to do this though, and the other way to do this, and there's your value there. You could also do 1.25, hit this little caret symbol. The caret symbol will, in some calculators, raise this, in other ones it will keep the little caret symbol, or the hat, some people call that a hat. And then you can also just type in a 2 there. So if you want to do something other than square, then you can definitely use your calculator to do that. You'll see we get the same value though, so for squaring it doesn't really matter. You can push the x squared key or do your caret or your hat over here and then do your 2, and you'll wind up performing the same operation. So it looks like we've got 1.5625. Notice how we're not asked to round this at all, so we don't want to lose any value. We want to keep all of that there. So 1.5625 will work. In the next problem, we've got x times y when x is equal to 2 and y is equal to 4. Even though there's two variables in this problem, we can still use substitution to help us out. So this x is going to come out. We're going to replace that with a 2. And then we've got a y here being 4. This is a problem for us if we don't use parentheses. You could use parentheses around both the 2 and the 4 if you wanted. That would kind of look like this. And now we know that we're indicating multiplication. If you forget to do that, you might mistake your answer for being 24, when really this statement right here, this expression, means a variable x times the variable y. So the variable x is 2 times the other variable y, which is 4. When we perform this operation, we get 8. Part D is similar. Now we have an x and a y, and they're taking on a little bit of a different value. So let's work with these, and let's replace the correct variable. And this is a tricky part here because the y comes first in the expression, but then the y comes last in our statements here of what each one of those variables is worth. So I always look at the variable, and then I look at my knowns over here, and I take the variable, and I can only substitute that value that the variable is equal to in for that variable. So now we've got a x here, which is negative 1.2 minus 2. Now you might be getting a little bit afraid of this one, and you might be saying, my goodness, Mr. Valsa, there's too many negative signs. Well, let's use our knowledge of order of operations to simplify this, and I'll show you that even though this looks a little bit complicated, you can get this done, and it's not as hard as you think. So what we're going to look at is we're just going to look at our order of operations. We know we want to work inside here first. We've got a negative value, and we're subtracting 2. So we're going to wind up with a larger negative value. This minus sign has to stay. We're just going to work with the parentheses. Negative 1.2 minus 2 is negative 3.2. This one's a little bit tricky here. You can think about this if you want as being a negative 1. That helps me sometimes because now I know that I have to take negative 1 and multiply it by negative 3.2. A negative times a negative is a positive, and 1 times 3.2 is just 3.2. So you may have heard another teacher in your past, and you'll probably hear it in your future as well, say, hey, when you multiply a negative and a negative, that's a positive. So here's what that looks like. Again, if you want to put that little 1 there, you're not changing the value of this by just putting the 1 there, but it does help you see that negative 1 times negative 3.2 is positive 3.2. Be very careful with your negative signs. Now we have negative 2 plus 3.2, which works out to be positive 1.2. Notice how you're taking a negative value and you're adding a positive value that's bigger than 2. So you're definitely going to wind up with more positives than you have negatives, so this answer should be positive.